Hello Year 10 and welcome to Straight Line Graphs Lesson 10. On the screen you can see just about the answers to the exercise from yesterday's lesson. So if you could mark your work, this one right here is a third and this is a half, and this is negative a quarter and negative a quarter, and this is a half, and this right here is negative a third. I think apart from that it's a little blurry, but you should be able to see what the answers are. So if you could pause the video and mark your work, and then we'll continue with today's lesson. Okay, so we're going to talk about two different things today. We're going to start by thinking about identifying two lines that are parallel from their equations. So on the screen here you can see I've got two lines, and I've labelled these with their equations. So this is the line y equals 3x add 9. You can see that too because it's going through 9 on the y-axis, so that's the intercept, and then we're going along 1 and up 3, so that's the gradient. This one right here, y equals 3x add 2, its intercept down here is 2, and then again we're going along 1 and up 3. Now hopefully what you can see is that these two are like train tracks, so these are parallel lines. That means to say that they are never going to intersect. We're never going to be able to read off a point where these two lines cross, because we can carry on drawing them as long as we like and they never will. And the other thing is that they have the same gradient. So this value in front of the x, this coefficient here, m, in both cases is 3. So we don't need to draw the line to see that they're parallel. We can actually tell that from their equations. Okay, so I've got a bunch of equations on the screen here, and what I'd like you to do is to pause the video and see if you can put them into pairs of lines that have the same gradient, pairs of parallel lines. Okay, so these are the pairs that you should have put them into. So this one right here, we've got 3x in both cases, so they've got the same gradient. This one down here is slightly different because I changed the order, and it's important to remember the gradient is the number in front of the x, not necessarily the first number in the equation. So this one's got a gradient of 2, as has this one, so these two are parallel. I'm going to save this one for last. This one here, again, they are in a different order, but they've both got a gradient of -4, so these two are parallel. This one, we have an intercept of 0 in the top one, but they both have a gradient of 6, so they're parallel. And I tried to catch you out here, but hopefully you realise that x divided by 2 is a half of x, so these two are the same. They both have a gradient of a half. Now this one here is a little bit trickier. We can't read off the gradient from this one in the form that it's in, because it has to be in the form y equals mx plus c. And at the moment, this 2x is on the wrong side. So we would have to subtract 2x from both sides to get it in the right form. And then that's how come it pairs with this one, because actually we would end up with y equals -2x add 3. So these two have the same gradient. Okay, so that brings us on to what we're going to be doing for the rest of this lesson, and that is reading off gradients and intercepts from equations, but sometimes we have to rearrange those equations to be able to do that, because our equation has to be in the form y equals mx plus c. So this is the one I was just talking about on the previous slide. We need to rearrange that, and we're going to need to use our solving equations skills here that we did quite a while ago. We're going to need to subtract 2x from both sides, so that will give me y equals 3 subtract 2x. Now you can read off the gradient and intercept in that form, but if you'd rather, you can then swap the order. So y equals negative 2x add 3. But if you're going to do that, it's important to realise that this negative here belongs to the 2x term, so you have to move the negative with it. Now I'm in a position to read off the gradient, which is negative 2, and the y-intercept, which is the coordinate 0, 3. You've got to give this as a full coordinate, not just as 3. Okay, so something's gone wrong with my animations here because we can already see the answer, but let's plow on anyway. So my equation here is 3y add 12x equals 6, and I need to rearrange this to get it in the form y equals mx add c. So I want to subtract this 12x from both sides first of all. So I'm going to subtract 12x from both sides, and that will leave me with 3y equals 6 subtract 12x. Now this still isn't right, even though I've now got just y's on one side, because I've got 3y, and I can't have 3y, it's got to be just y equals. So I now need to divide both sides by 3. And it's important to realise we're dividing this 6 and also this negative 12 both by 3. And that means I'll get y equals 2 subtract 4x. So 6 divided by 3 is 2, and negative 12x divided by 3 is negative 4x. And now this is where my answers over here that we could already see came from, because my gradient is negative 4 and my intercept is 0, 2. If you rather, you can swap these around so long as you remember this negative belongs to the 4x there, so that has to move with it. And that then you might prefer to read off the gradient in the intercept from this. Okay, again, I have forgotten to animate these two, but not to worry. This is my equation that I have to rearrange. I'm going to ask you to pause the video to see if you can do the full working to show what you need to do here to get it in the form y equals mx plus c. So pause the video and see if you can do the correct working. Okay, so what we need to do here is add 6 to both sides, because I only want my y on this side, so I need to get rid of this negative 6, and I'm going to do that by using the inverse operation and adding 6 to both sides. And that will leave me with y equals 7x add 6. And now I can read off the gradient. So the gradient is 7, and the intercept is the 0.06. Okay, looks like I've animated this one. So this one is super tricky. I'm going to give you a minute just to see if you can do it. You need it in the form y equals mx add c, like before. And there's a couple of things you need to do to this. Actually 3 things you need to do to this to get it in the correct form. So pause the video and see if you can do the correct working. Okay, so first of all, and you might have done this in a different order, which would be fine, but you should end up with the same answer if you've done it correctly. So first of all, I'm going to subtract 11x from both sides, and that's going to give me 2y plus 5 equals negative 11x. But I also need to get rid of this plus 5, so I'm going to need to subtract 5 from both sides, and that's going to give me 2y equals negative 11x subtract 5. Now you might have subtracted 5 first and then subtracted 11x, which would be fine. You would have still got to this point. Okay, so then finally I need just one y on this left hand side, so I'm going to need to divide both sides by 2. But I have got some shockingly horrible numbers here, and I've done that on purpose just to show you that when that happens, you can just leave them as fractions. So 2y divided by 2 will give me y. Minus 11 divided by 2 will just give me minus 11 over 2, which I can write as negative 11 over 2. And then minus 5 divided by 2, well, that's just 5 over 2, and negative 5 over 2, so I can leave that as a fraction. And now I can read off that the gradient is negative 11 over 2, and that the intercept is 0, negative 5 over 2. So just because the numbers are really nasty doesn't actually make this more difficult, just leave it as a fraction. Okay, so this is your task for today. Now, some of these are quite tricky and some of them are a little easier than others. So, you know, this is hard. You're going to need to give it your best shot, but you might find it a little difficult. Show full workings. You need to rearrange each of these equations so that they're in the form y equals mx plus c, and then write down the gradient and the coordinates of the y-intercept. So that's always going to be 0 something. There's a little extension question at the bottom here, which is to identify which two of these equations are actually exactly the same. They're just different rearrangements of the same equation. So this is tricky. And check back for the answers next week. Tomorrow, I'm going to ask you to do a Dr. Frost assessment.